Welcome to qnawire.
Hello. For the system shown in the screen, we have to calculate the following parameters, which are listed here. But first, prior to the calculation, we have to calculate the geometry of the system. As we know, these distances from 1 to 2 and from 2 and 3 are L, as well as the distance from point 2 to point P. So now let's modify this drawing a little bit. So we'll connect points P and 1, and we'll connect points 3 and point P. And we'll also draw a line through the point P, which is perpendicular to the line 2P. So now we will label several angles. We'll label this angle as angle 1. This angle will be angle 2. This angle will be angle 3. Then angle 4, and then angle 5. So now we have to calculate these 5 angles. Although it looks a little bit complicated, it's not in reality. So let's look at the triangle 1 to 2P. Sorry. Yeah, from triangle 1 to P, we see that the angle 1 to P is 90 degrees, and the distances between points 1 and 2 and distances between points 2 and P are the same and equal to L. Therefore, the angle 4, which is this guy, equals to 45 degrees. And the distance from between points 1 and P equals to L multiplied by square root of 2. In the same way from triangle 3 to P, where angle 3 to P is 90 degrees, this guy, the distance between the distance between points 2 and 3 equals to the distance between points 2 and P, which is L. And according to the same principle, angle 5 is 45 degrees. And the distance between points 3 and P equals to L multiplied by square root of 2. So these are two important parameters which we need to know for the later calculations. So this guy is L multiplied by square root of 2. So is this length. Okay, we found two angles. We have to find 3 more. So angle 3 plus angle 4 equals to 90 degrees because this is perpendicular. So therefore, angle 3 plus angle 4 is 90 degrees. Therefore, angle 3 equals to 90 degrees as well. Sorry, to 45 degrees as well. So now we have to calculate angles 2 and angle 1. How would we do it? So basically in the following way. The angle P32 equals to the angle 2 because basically angles formed by 2 parallel lines and 1 common line. So it equals to 2. And from the triangle P32, this angle is 45 degrees. So it means that angle 2 is 45 degrees. So angle 2 equals to 45 degrees, and angle 1 equals to 90 minus angle 2, which is 45. So let's summarize our finding for now, which is very important for this task. Angle 1 equals to angle 2 equals to angle 3 equals to angle 4 equals to angle 5 equals to 45 degrees. So now we did a very important thing. We calculated the geometry of the system. Now let's redraw it, and we can proceed answering this question. So basically now we can calculate the electric field. Again, so here are our points 1, 2, and 3, and this is point P. So first charge is negative, second charge is positive, third charge is positive. So now let's show each individual component of the electric field at point P. The first charge is positive, it's negative, therefore the electric field created by the first charge will be directed to this charge. So this is E1. E2 is second charge is positive, therefore the field will be directed from the second charge, so it will be directed upwards. And the third charge is positive as well. Therefore, it will create a field which is directed from the third charge. So this is E3. Now we have to introduce a coordinate axis. So we can simplify our life a little bit and direct X to the left. Just as we see, both E3 and E1 have a component which is directed to the left. But the choice of the direction of x-axis is not principal here because it will only change the sign, but not the absolute value. And y-axis is directed upwards. So now let's write down the formula which control the total field at point P. This is a vector sum of the individual electric field created by each charge. Or if we are interested in the x projection, we have to take the x projections of the first component, of the second component, and of the third component. So as we can observe, the second component is perpendicular to x-axis, therefore its contribution will be 0. So this guy equals to 0, and this equation simplifies to E1x plus E2x, sorry, E3x. Now let's calculate E1x and E3x. E1x equals to E1 multiplied by, so we need this angle, which is angle 3. So x component of E1, this length, equals to E1 multiplied by cosine of angle 3. Cosine of angle 3, which is E1 multiplied by cosine of 45 degree, which is E1 divided by square root of 2. Right. E3 equals to E3x equals to E3 multiplied by cosine of angle 2, because we need this length. Or it equals to E3 multiplied by cosine of 45 degree, which is E3 over square root of 2. So therefore, Ex at point P equals to E1 over square root of 2 plus E3 over square root of 2, which is 1 over square root of 2 multiplied by the sum of E1 and E3. Now we have to calculate E1 and E3. E1 equals to K, electric constant, multiplied by Q1, divided by the distance between points 1 and P squared. Or it equals to K multiplied by Q, multiplied by Q1, right? Multiplied by by this guy squared, which is 2L squared. In the same manner, E3 equals to K multiplied by Q3 divided by the distance, by square distance between points 3 and point P, which is also 2 multiplied by square root of, L multiplied by square root of 2. So this guy equals to KQ3 over 2L squared. Now we can complete the calculation. So EX at point P equals to 1 over square root of 2 multiplied by the sum of KQ3 over 2L squared plus, KQ1 over 2L squared plus KQ3 over 2L squared. So it equals to K over 2 square roots of 2 multiplied by L squared and multiplied by the sum of Q1 and Q3. Let's calculate this number. K equals to 9 multiplied by 10 power by 9 newtons multiplied by meters squared divided by coulomb squared over 2 square roots of 2 multiplied by 0.200 meters squared multiplied by the sum of the charges, which are 2 and 6. So here, I have to state that we take an absolute value of Q1 because we've already taken into account the direction of the field. So here Q1 will be just positive, so which is 2 multiplied by 10 power by negative 6 coulombs plus 8 multiplied by 10 power by negative 6 coulombs. So now I have to use a calculator to calculate this number, right? 2 and 6. Oh, sorry, my bad. It's 6 microcoulombs. So let's do this calculation. So it equals to the following number. Volts per meter, which equals to roughly, so we have to take 3 decimals because charge and the distance has 3 decimals, so it equals to 6.36 multiplied by 10 power by 5 volts per meter. So this is EX. Okay, and this is a question, answer to question A. Now we have to calculate EY, Y component of point X. So let's do this. Y component of point X will be the sum of 3 contributions. So it equals to E1Y taken with a negative sign because it's directed downwards, plus E2Y and plus E3y. Right. Now let's calculate these components. E1y equals to E1 multiplied by sine of angle 3, which is E1 multiplied by sine of 45 degree, or E1 over square root of 2. E2y equals to just E2, which is k multiplied by Q2 and divided by L square, because the distance between points 2 and P is L. And E3y equals to E3 multiplied by sine of angle 2, which is E3 multiplied by sine of 45 degree, which equals to E3 over square root of 2. So now let's continue. Yeah, let's complete this calculation. So again, we have to finish the calculation of E1y. It equals to E1 over square root of 2. Or frankly speaking, it's easier to do it in a little bit different way. So EY at point P equals to E2y plus E3y minus E1y, which equals to KQ2 over L squared plus E3 over square root of 2 minus E1 over square root of 2. So which equals to KQ2 over L squared plus again E3 equals to, so let's simplify it a little bit, 1 square root of 2 multiplied by E3 minus E1. So similar to the previous part, but just with a negative sign instead of sum. So this guy doesn't change, plus 1 over square root of 2 multiplied by k q3 divided by 2l squared minus k absolute value of q1, because we've taken into account the charge direction of the sign of a charge already, divided by 2l squared. Now let's finally simplify this expression. So kq2 over L squared plus k over 2 multiplied by square root of 2 multiplied by L squared, and it's all multiplied by q3 minus absolute value of q1. So now let's simplify it again. Yeah, it's a little bit long calculation. So it equals to k over L squared multiplied by q2, right, plus 1 over 2 square roots of 2, all multiplied by q3 minus absolute value of q1. Finally, yeah, now we can calculate it numerically. EY at point P equals to K, which is 9 power multiplied by 10 power by 9 newtons meter squared divided by coulomb squared divided by 0.200 squared meter squared multiplied by Q2, which is plus 4, yeah, 4.00 multiplied by 10 power by negative 6 coulombs plus 1 over 2 square roots of 2 multiplied by 6.00 power by 10 minus 6 coulombs, negative 2.00 multiplied by 10 power by negative 6 coulombs. Okay, finally we can complete this calculation. So here I need to use a calculator. It equals to the following. Which roughly equals to 1.28 multiplied by 10 power by oops, sorry, I missed one number. So then it will become 1.22 multiplied by 10 power by 1, 2, 3, 4, 6 volts per meter. Okay, so we've calculated Y component of the electric field. And now we can calculate an absolute value of the electric field. So it equals to the square root of Ex squared plus Ey squared. Because here, if we redraw this again, so let's say this is point P, so Y will be directed somewhere upwards, X is somewhere here, so Ey, E total is the sum of these two vectors, and therefore its length can be calculated as shown here. So then, okay, let's calculate the number. Sorry. So Ex is here. Plus Ey. Okay, what does it equal to? So here I have to use a calculator again. So it equals to the following. Yeah, this is the total electric field at this point. So at point P, now we have to calculate the direction of this field. So let's sketch the system again. Pardon me, bad drawing. So let's say this is point P, point 2, point 1, point 3. So Y component is directed up, and it's longer than it's higher than X component. So this is E total. And now we basically have to find this angle alpha. Alpha equals to a tangent of EY over EX, which equals to a tangent of, let me use a calculator again. Which equals to a tangent of 1.914, which is roughly 62.4 degree. So this is a direction. This is the direction of the electric field at point P. So it means that this vector is located at 60.2 degree with respect to the line which connects points 1, 2, and 3. So this angle is here. And it's like basically the total electric field at point P is located to the left top corner of the screen. So let's summarize this finding. Direction to the top left corner, and angle is 62 degree C with respect to the line which connects points 1, 2, and 3. So let's summarize our findings because it's been a pretty long task. So for question A, the answer is 6.36 multiplied by 10 power by 5 volt per meter. For question B, it is 1.22 multiplied by 10 power by 6 volts per meter. For question C, it is 1.37 multiplied by 10 power by 6 volts per meter. And for question D, it is 62.4 degree to left top. So this is the answer to this question, and the solution is presented here. It's been pretty long, but I strongly believe I helped you. So thank you very much for the task. Bye.